Okay. So here we've got a couple charges. So we've got x, y, and now we're placing a 20 nanocoulomb charge at 2 meters and a at minus 3 meters in the y direction. We've got a negative 25 nanocoulomb charge, and it wants to know what is the direction of the electric field at the origin. So electric field is a vector quantity, so it's 1 over 4 pi epsilon naught. The charge over r squared times r hat, which we can write as 1 over 4 pi epsilon naught charge over r cubed times the r vector. So start off for the first charge, r10 is the distance to the origin minus the first distance, so 0 minus 2 meters x hat, which is then just minus 2 meters x hat. So there's our vector. Our r is just the magnitude, which is then just 2 meters. So then our E field is 1 over 4 pi epsilon naught times our charge, which is 20 times 10 to the minus 9 coulombs, over our 2 meters cubed times our minus 2 meters x hat, which comes out to be minus 44.94 newtons per coulomb in the x hat direction. Now our r20 vector is again just r0 minus r2, which is 0 minus our minus 3 meters in the y hat direction, or just a positive 3 meters in the y hat direction. So our E field is 1 over 4 pi epsilon naught times our charge, which is minus 25 times 10 to the minus 9 coulombs, over our 3 meters cubed times our 3 meters in the y hat direction. And that comes out to be minus 24.97 newtons per coulomb in the y hat direction. And so now if we look at this, x, y, so our force, or our electric field, sorry, is our total electric field is the sum of the two, which is minus 44.94 in the x hat and 24.97 in the y hat. So nothing really to add up there. And so we can get our angle, or at least we can get our angle in here as tan gamma. I'm just going to call that gamma. Is opposite over adjacent, so 24.97 over 44.94, which gives us an angle of 29.05 degrees. Now, we always measure it from the x-axis, so we need to get that whole angle. So the theta we're looking for is 180 plus gamma, so 180 plus 29.05, which comes out to be 209.5 0.05. And if we look at the answers we're given, D, 209 is the closest to this angle. Checking through the solution here. These are vector quantities. So EX is 44, EY is negative 25. So we need to add 180 to the angle, and we get 209. So that's the magnitude. Oh wait, what? How did you get that? Oh yeah, okay. So that's the magnitude. Okay, so that looks good. And I'm actually going to stop here now and say thank you all for watching. If you enjoyed this, please subscribe to the OneClass channel. If you want to leave questions, please follow please look below the video. This has been Jeff Kress for OneClass, and I hope to see